here. So I'm going to keep it fairly simple, but I'm going to focus on one specific technology today. But we're going to talk about how to add smart factory value to your existing equipment. Really, I always like to start with, what are your goals? I mean, what are you trying to do? Probably you're trying to reduce downtime, understand plant health, improve productivity, those kinds of topics. But are you trying to just understand the overall plant's production levels and OEE, or maybe you're interested in just one machine's health or one area, one machine is giving you the most headache. So, what are you trying to accomplish with a machine? Are you trying to look at the production output of that machine, or the OEE, or the uptime of that piece of equipment? Or maybe you have a critical piece of equipment, a motor on a conveyor belt that moves your parts around, and without it, you can't move refrigerators through your plant without that motor. Critical pieces in the facility that really are important for you to monitor and to understand what's going on. So are you trying to look at component health of devices? And these components typically provide clues before they fail. And the question I always like to ask is, if this component failed, we would be screwed. And so think about, in your plant, if you had a component fail, you'd be in big trouble. Think about what those are and how many of those are in your plant. If this component failed, we'd be screwed. And we're going to talk about some examples of that today in this presentation with some real world case studies. So the thing I want to start with, though, is, you're only as strong as your weakest link. So, you may have a complete production line with lots of machines and lots of conveyors moving around your plant, but if you've got an old motor you're not taking care of in a dark, dusty corner, that can cause catastrophic downtime problems inside your production plant. And so that's something that really has to be considered when we're looking at our facility and our equipment. What is the weakest link in our equipment, and how do we make sure that it doesn't fail? How do we make sure that it survives to last another day? How can we provide some maintenance to that before it fails so it doesn't fail, or at least we can do a controlled shutdown rather than a catastrophic shutdown? Downtime is killing us. That's really what we're going to be here to talk about today, is downtime's killing us. From Industry Week, downtime incidents are costing us about $17,000 per incident in general in a production plant. As a survey from Industry Week. In Garvey's survey, they found that there were about 800 hours of downtime every year in a production facility. And this one in the automotive industry is just shocking, $22,000 per minute. But I'm actually not surprised about that. I've been to an automotive end user where, if the production plant is down, it's over $1 million an hour of downtime, and it kind of makes sense. I went on the Toyota TMMK tour a couple years ago, and they said they make a Toyota Camry every 50 seconds. I mean, how much does a Toyota Camry cost? And they make one every 50 seconds. So you can see how $22,000 per minute of downtime can be significant in the automotive industry. And so, and that's a realistic number, even though at first when I read $22,000 per minute, it seemed a bit shocking and overwhelming. But if you think about it logically, that's a pretty valid number. So the other trouble is, a lot of equipment like a pump for cooling liquid, or maybe you have a hydraulic power unit down in a basement below a stamping press, or maybe you have something up on top of a piece of equipment, like you have a 6-axis cutting machine, and there's a drive or something up on the top of the piece of equipment. A lot of this stuff can be hard to reach, right? And so if it's inside a confined space or it's underneath a piece of equipment, you have to have people with special permits and special equipment. Maybe they need hazmat training or hazmat gear to get into that space. So confined spaces and under equipment, it can be really hard to reach. So to go in and do condition monitoring or maintenance on that, or checks on that equipment, it's not something someone wants to do, and it's really hard to do. And then, of course, if things are high up at the top, like this is in the top of the crown of a stamping press, you've got to get a man lift and safety equipment and rigging, and you've got to do a lot of work to get someone up there to do to do condition monitoring checks on the top of the press. But this is important, right? That's the flywheel that runs the press. So you want to make sure you're monitoring the condition of everything going on there, the brakes and the bearings and the motors and everything, and the gearbox, right? So when we're looking at this, these things can be hard to reach, and so condition monitoring might be challenging. But even if this stuff fails, we can detect failure before catastrophe, and that's something we have to really think about. This is a standard PF interval diagram for condition monitoring. This is just a generic one, but there's all kinds of indicators for a device before it fails, typically, that we can possibly detect. So, what is the deterioration? Is it from lubricant analysis or vibration analysis? Can we look at pressures or humidities, noises, heats? And then if something's smoking, we all know, that thing's pretty close to failure if it's smoking. But there are a lot of indicators before that, especially heat and vibration, that can be utilized to prevent catastrophic downtime. And so we want to be able to detect failure before catastrophe as best as we can. And how do we get more time to react to prevent that functional failure? So what can I do that's easy and inexpensive in these times? That's really something we have to think about. A lot of companies do condition monitoring. They might hire a service, or they might have maintenance crews that go out and monitor on a monthly or a quarterly basis certain components. You could see on the left, periodic condition monitoring, and maybe you pay a service, or maybe you have an individual that does this in your maintenance staff. Are they trained properly for doing that? Has the equipment been calibrated recently? Are they putting it in the right hole or mounting it on the right place to get the right values comparable to the last time that you took measurements? All of this can have an impact on the data. So that's periodic condition monitoring. And then you have continuous condition monitoring, where you permanently mount or semi-permanently mount a sensor onto a piece of equipment, and you monitor it every second of every day and collect data on the function of that device. And so, you have to think about, when thinking about condition monitoring, can we get away with periodic, or is continuous condition monitoring better for us? So, Chris, we have a second poll. If you could throw that up, or turn on that poll, if everyone could turn to the poll. The question that we have is: are you currently performing condition monitoring in your factory? Are you doing that with an outside service? Are you doing it with a maintenance team? Do you have some continuous monitoring and some periodic monitoring? Or are you doing nothing at all? What kind of condition monitoring are you doing of your motors and drives and fans and bearings? So we've got the poll there. I'm going to keep going, but please give us your answer in the poll. What are you thinking about, and what are you doing? Definitely, and we'll poke back to that and talk about it at the end of our presentation. So what is continuous condition monitoring? And that is, if you're not aware, that's monitoring the status and health of machines, plants, or individual components like a bearing or a linear drive. And continuous condition monitoring detects changes and anomalies by recording long-term trends and statistical evaluation. And a lot of people, when they hear statistical evaluation, they think, OMG, I've got to do statistical evaluation. That sounds horrible. I don't have time for that. We don't have the database for that. And what's cool is that I'm going to show you a technology that actually has a lot of function built into it to do some of that analysis and trending for you inside of the device, so you can use it more just like a regular sensor. So, but we'll talk about that in a second. So where can you use a conditioning monitoring sensor? There's lots of places. I would say anywhere you have rotation is a place where catastrophic failure occurs regularly. Maybe not regularly, but definitely occurs. So many places for potential failure: worn bearings or worn belts, frictional rubbing between two mechanical components, unbalanced or soft foot, loose bolts on a motor. Particle accumulation on a fan blade can cause issues, can cause imbalance of the fan blade, and then cause wear or frictional rubbing. A lot of these come together as multiple pieces. Displacement, misalignment, or collision of two components. And then even thinking not necessarily the device failing, but just it's in a weird place. Maybe you have a pump house, right? You have a well off on your property, but it's out in a back room somewhere far away. And yeah, okay, you've got internet out there and you've got power out there, but are you monitoring that stuff? How often does someone go out in the pump room and check things out? And then inside of electrical cabinets, especially if you're in food and beverage, you're doing wash down. Did everyone close the electrical cabinets before they did wash down service? Is there extra humidity inside your cabinet? Or is there moisture buildup inside of the cabinet? These are things that we want to check because it can really be damaging. So really, the goal of condition monitoring is places where we're having machine downtime. Can we monitor the mechanical components, machines, and the factory so that we can improve that overall plant productivity? So the device I'm going to talk about today, just briefly, I've got, I think, one, maybe two slides on this, is the new Balluff condition monitoring sensor. It has multiple measurement values built into it: vibration, temperature, ambient pressure, and humidity. There's two variants. One allows you to have a more IP67 rating, and the other one has a lower rating. All of a sudden, I'm blanking. But depending on what you're trying to do and what you need to measure, there's two different part numbers based upon that. But what's really neat and cool, and I've hinted at already, is the data pre-processing. So we have the ability on board of the sensor to do some standard statistical evaluation and parameters and set those as basic outputs of the sensor device. So we can set highs and lows or bands or different RMSs or means, and we can actually trigger that as an output or a measured value that comes out of the sensor. So it's a configurable output. Then we have events and status indications. So like I talked about, so monitoring those self-described thresholds. And then you can get process data of different types. So if vibration's most important to you, one axis or three axes, or the temperature is most important, or some calculation based upon vibrations. You can take all of that and decide what data you want to come out of the sensor. The housing is very small. If you're familiar with the flat pack prox housing, it's very comparable to that. So I think it's like 12 by 30 millimeters or something close to that. So a real small little form factor that you can mount on a machine or on a small motor. It's a stainless steel housing, so you get that 67, 69K that I mentioned when you're not collecting ambient pressure and humidity. And then it has an IO-Link interface. So I'm not going to dive into IO-Link today. If you want to learn more about it, definitely reach out to me and we can talk about what IO-Link does. It's like USB for automation. So if you've never heard of it before, it should be not scary to you. It's very simple to implement if you have modern day industrial controllers. And then last but not least, it has standard M12 connectors. The condition monitoring sensor, really the trick here is it's one sensor that you can use for a lot of different applications. And I'm going to give you some case studies here in a second of how people have used it in a wide variety of applications. But the key thing is here, you don't need some sort of specialized software or some sort of external database and diagnostic controls or complicated programming or interface. It sets up very simply using that IO-Link communication protocol and parameters, which you're familiar with if you used IO-Link before. So it's a neat little sensor, and the feedback that we've gotten over and over as people have implemented this sensor is that it's easy to set up, it's easy to use, it's easy to get good condition monitoring value out of. So it has one sensor with lots of possibilities and really an easy integration. So if I clicked, there we go. So your question always is, and I know my question always is, that may be cool, but who bought it before me and who's actually doing this? So I'm going to share with you 6 case studies. I got a lot more than this, but I'll share 6 with you now. And if you're interested in seeing more case studies or learning about applications in your specific industry, reach out to me, reach out to us, and we can set up a conversation about your specific industry. But here's a wide variety. This is a chain conveyor drive in an automotive tier supplier. There you have thousands of feet of chain conveyor that with multiple synchronized drives. You can see the sensor there in the middle on the gearbox. And so what they're doing is they've got a bunch of drives that drive the chain and drive the belt. And the problem is if one of the drives goes out of sync, the chain buckles and crashes, and this causes major production downtime. More than 10 hours. One time they said 16 hours of downtime they could make no parts when this conveyor was down. And so they were able to use a condition monitoring sensor on each of the gearboxes. And as soon as they detected excessive vibration in the gearbox, they alerted maintenance. They performed a controlled shutdown instead of a crash of the equipment. They performed a controlled shutdown, replaced the belt that needed to be replaced, and were able to get up and running much faster than that 16 hours of downtime they had before. So really a powerfully simple solution here. And all they were looking for was excess vibration. So they could set some basic thresholds. They integrated it into their existing controller and HMI with just some straight bits. So really powerful to be able to do that and implement that with their existing control equipment. This is a stamping press. So this stamping press is for the whole machine health. So they were having issues where certain die sets were being loaded in the press, and shock was being generated from snap through from some of the dies, but not all of them. And this was damaging the press over time. And so they're using vibration monitoring to monitor the peak and the average vibration values during a run. And then they could analyze which tools were causing the hardest hits. And so by identifying those tools that were causing the hardest hits, they then gave that information to the die engineers, and they were able to make modifications to the die sets to lessen the shock and reduce damage to the press over time. Really powerfully simple implementation for them to just really monitor that peak and average values. And whenever they saw tied to the tool sets that's loaded, they could actually see which tool sets were causing the certain amounts of vibration damage. So really powerful. This is in a candy factory. This picture isn't the actual factory. I just have a representative picture here. But they implemented a plant-wide monitoring program. They had dozens of locations with multiple motors and drives moving lots of conveyors. And they wanted to implement a complete plant-wide condition monitoring. So they wanted to be able to monitor the entire condition of the plant. And so they implemented temperature, humidity, and vibration so that they could kind of have like a heat map across their whole plant in their SCADA system. And in their monitoring room, they could see what is the kind of heat map, the temperature, humidity of all the whole area of the plant, and then vibration of individual components. And so this system helped the customer with some insights, and they were able to improve the OEE of the entire production plant by implementing this program. So that is really powerful. What they were able to do, and they implemented dozens of sensors into the plant across the facility so that they could get that kind of plant-wide view of their production process. And as you can imagine, in candy manufacturing, humidity and temperature have major impact on the production. So they want to know if something's going on in a certain area. I already kind of hinted at this application, but this is a really good one. We've had this one a lot, and so that's why I want to talk about it. But these unstaffed, or what you want to call decentralized pump houses, maybe they're supplying lubricants. They might be outside the plant, pumping from a storage tank into the plant. Maybe it's a cooling water system or an HVAC system or something like this, where you have it outside or you have it out in a remote building, and they're supplying that material or that process to the production. The pumps can be everywhere and anywhere, on top of buildings and underground and in tunnels and out in a lot somewhere. And so we have the possibility that no one sees those devices, or those devices can go unstaffed for days or weeks or months at a time. So, the task to manual monitor those and go out and check them and run down a checklist on all those things, that's regularly the least favorite task, the unpopular task of the maintenance crews. Might get designated to the low man on the totem pole, and so maybe they aren't fully trained on how to execute that properly or do it. Maybe it was given to a co-op to do. Actually, one of my jobs when I worked as a co-op, in my second co-op ever, actually, just thinking about that. But the manual monitoring and documentation, and if they're not trained to take the values right, the data can be questionable then. And I've heard that feedback from a number of people. So the ability to use a condition monitoring sensor to be able to mount that on the device that's remote and then reliably and easily collect that data so that we can analyze it in a place where people are, that can really help in an application. And then I believe this is my last case study. Inside a controls cabinet monitoring, moisture, humidity, high temperatures inside a controls cabinet can really destroy sensitive components and terminations. You could actually detect, depending upon the plant, you could detect if a cabinet's left open or if a cabinet's been sprayed inside during a washdown process. If you've got humidity and pressure measurement there, you could see a spike in the values. So, there's options to understand better what's going on with your controls cabinets and what's going on there based upon changes in temperature, pressure, humidity, and even vibration. So, oh no, here's my last story. Great. I thought I had. I was sad I didn't have this one in here, but it is in here. So this one's really cool. Welding, anybody welding or anybody generating fumes in general, if you've got air handling equipment, this is something that you probably have. This is a welding fume scrubber system. And so, a welding fume scrubber collects air from the welding process and allows them to process that air and then eject it. So these fans can accumulate buildup on the fan blades. It can be a hazardous, it requires hazmat training to go inside this thing. It requires confined spaces training to go inside this thing and to clean the fan blades off. And so, and especially if something gets damaged or broken, it can be a huge hassle to try to repair this. You have to take the whole thing apart. So you can see that we're monitoring on the motor, we're monitoring on the bearing, we're monitoring on the fan itself to understand what's going on this piece of equipment and if anything occurs. And this was easily integrated into their regular PLC and controller. They set some bands and some basic data sets, and then we're able to monitor this welding fume scrubber. So it wasn't a bunch of extra work or database analysis for them. They're able to implement it very simply. So how do you get started with this? That's really the ultimate question that we want to try to lead with and make sure that, it might be interesting to you, but how do you get started? Condition monitoring is pretty straightforward with this device to do simple applications. Of course, there's super complex applications. You have to think about what's going into the application. But I really liked this article from Control Engineering, and they talked about 4 condition monitoring project steps. And so I'm just going to steal from Control Engineering because it's really good advice. So do a criticality analysis. Conduct this analysis in your plant. What assets, what machines, what components have the most impact on our bottom line? What is having the most effect on our downtime? And so look at what those critical components are. Identify 5 of them or one type of component or just one machine that's causing all your bottlenecks or your problems. Then think about what are probable failures. So identify the probable failures the asset will experience. So how has it failed in the past? What has happened to similar equipment? Past work experience? All these things come together. So what are probable failures that could occur with that equipment? And then what kind of technology is best suited to detect that failure? Can you do device level monitoring of a motor, or can you just do machine monitoring like we saw on that press? Is it periodic or continuous? Do you need really instrumentation to measure this, like you might get with a fluke meter or something, or is it more like a basic sensor? And then what kind of communications do you have available to collect data and see that? Are you using industrial Ethernet protocols or what's possible for collecting that data? And then last but not least, how do you analyze and execute? And I think sometimes this is scary to think about how we're going to do analysis and how we're going to process the data. But it doesn't have to be scary, and it can be easier than it first appears. But how do we trend and analyze the data to plan and execute maintenance actions at the most advantageous time? So instead of only fixing things when they're broken, how do we make sure that we're planning ahead and fixing things before they break, and reduce that unplanned downtime and extend our asset life? So, the inside the condition monitoring sensor I presented earlier, we can actually do some of those analyze and execute steps inside of the technology. And with the iLink communication, we can actually communicate almost over most industrial communication protocols, and it allows you to do continuous monitoring. Of course, you can use a continuous monitoring sensor for doing periodic monitoring, and you can use it for doing device or machine or plant level monitoring. So there's a lot of options and things that we can do to monitor equipment inside a production plant. So my suggestion is, and again, the suggestion of this great control engineering article was, start with a pilot. The people who really are most successful that I've worked with, and the people who are most successful that this author worked with, start with a small pilot. You have to get buy-in of the maintenance teams and the leadership team. If we don't have the maintenance team on board, we don't have the leadership team on board, of course the engineers have to be there to help make it happen. How do we get everyone on board with this project so they're aware? We have to document the positive impact. So when it does catch or it does notify us and we stop something safely, tell everybody. Tell them, this was great. Look at what it did. It saved us. Last time it took 2 days to repair it, and this time we were able to fix it in an hour and get up and running, and we had no downtime from it. So document the positive impacts and talk about the positive impacts. And then that'll allow you to probably get more money from management to be able to implement more condition monitoring, and it grows over time. So when we document those impacts, we have a much higher chance of getting more capital and more money and more budget to be able to grow it over time. So the thing is condition monitoring provides warnings about faults and makes it possible to schedule repairs all without unplanned downtime and lost production. And that's really the key thing here. We want to be warned before we go down, and it's very possible today to get that. And so you could start implementing this now on the most frustrating parts of your plant and get value very quickly. So what next? What do you want to do? Are you interested in learning more about condition monitoring? Do you want to talk about a pilot and how you can implement a condition monitoring application? Or maybe condition monitoring isn't something you want to talk about, but you want to talk more about downtime. Balaf really and myself, best practices for reducing downtime, that's what I do. That's what I talk about. It's my tagline on LinkedIn. I love talking about how we can reduce downtime. And there are solutions for doing that in food and beverage. There's solutions for doing that in welding and stamping and assembly applications and general factory automation applications. We can really talk about a lot of different ways to reduce downtime. Condition monitoring is for sure one that I'm passionate about and I think has a lot of value for every manufacturer. But maybe you're not sure it applies, but I'm happy to talk about how reducing downtime could be valuable to you. So let's connect with me on LinkedIn, follow me on Twitter, shoot me a text message and say, hey, Will, I want to talk, or reach out to your local Balaf salesperson and connect with them. If you aren't sure who that is, text me and I'll connect you with the right person. But let's talk about how you could get a condition monitoring pilot going and what we can do. So I believe this is my opportunity to turn it over to Chris. Chris, take it away.
Thanks, Will. At this time, we're going to ask a couple questions. I know that we are right at 12 o'clock here, so just so that everybody knows, there will be a recording replay if anybody needs to run that we will be sending out. But I do want to get to a couple questions that we have here. So we have a question from Marvin asking, how can I integrate the sensor into my machine?
Yeah, there's a lot of options. The one that most people that I've worked with, I've seen are using their industrial controller. So their existing Allen Bradley Rockwell controller, their Siemens controller, and use either, it has to have IO-Link. So, but Siemens makes cards that go in the rack or for their remote I/O system. So does Allen Bradley makes cards for the point I/O system. And Balf, of course, has IO-Link masters. You can see one in the center of this picture here that talk all the industrial protocols, so Ethernet IP, Profinet, and such. So the ability to connect the condition monitoring sensor to the any Ethernet protocols really, or even any PLC chassis is a pretty diverse option. IO-Link has over 300 companies in the consortium, so there's a lot of different options of technologies that can be utilized to get IO-Link connected to your machine.
Okay, thank you, Will.
Uh,
And I did.
Chris, I want to add one more thing to that. So, if maybe an industrial controller is in your option and you want to try to run a black box or an industrial hardened PC or something like that, there are ways to do JSON objects and REST APIs and UDP type traffic, just basic Ethernet type traffic. There are solutions for doing that as well.
Great. And I just wanted to let everybody know I did share our condition monitoring sensor one pager. There's obviously a lot of information that we have on our website and other places, but just a quick snidbit that goes over the features of the sensor there. I shared that in the chat here. And I think we'll have time for one other question. I have a question here that says, so let's go to this one here. How does the BCM compare to instruments that you can buy from companies like Fluke? I think I'm pronouncing that right.
Yep. Yeah, I did kind of hint at that a little bit, but if you're trying to do high level instrumentation level measurement of a function of a device, calibration of a device, that is not what the BCM is doing. So you can't replace a BCM solution with a $10,000 Fluke monitoring system, probably, if you're really using all the functionality of that thing. This is for monitoring general vibration and doing analysis of basic, is it out of spec kind of things. But if you're really trying to get into the nitty gritty, then yeah, you have to go with one of those higher end systems. But this, the price point of this really allows you to get it on more equipment and get continuous monitoring on more equipment. A lot of those types of solutions are for periodic monitoring and really have to be used for that.